All right, so here we have f of x is equal to x ln of x. So we have to think about what does ln of x look like. And so ln of x, if we remember, does something like this. And so we can't have 0 for our domain. So domain has to start at 0 and go to positive infinity. Now, where does it cross? Well, it crosses at x equals 1. And so x equals 1 is going to be our x-intercept. And so f of 1 will be equal to 0. And so that gives us our 1 comma 0 as far as where that is going to intercept. Okay. Now there's not going to be any asymptotes or anything like that in this one per se. And so let's go ahead and go on to the first derivative. Okay, so we'll take first times the derivative of the second. Well, that's going to be 1 over x plus the ln of x times the derivative of the first, which is 1. And that simplifies, so that's going to be 1 plus ln of x. Okay. Now, if we solve that and say 1 plus ln of x equals 0, that gives us ln of x equals a negative 1. E to that, so that gives us x equals e to the negative 1. All right. So that's going to be our critical number as well as our partition number. Okay. And with that said, we plug that in here, e to the negative 1. Now remember, at 0, we can't have that. That can be 0. So let's kind of look at the different places here. And again, this is the derivative. So here, this is going to be maybe a 0.1. So if we take the ln of 0.1, that's going to be a negative 2.3 plus 1. So that's going to be negatives here. Plug in 1. So if we have the ln of 1, that's going to be 0 plus 1. That's going to be positives. So that's going to be positives to the right. Okay. So if we're going down and we go back up, that means that this has to be what? A local minima. And so we're decreasing here and we're increasing here. Okay. And so if we write that out, we have we're decreasing from let's see, 0 up to e to the negative 1. And e to the negative 1 again is going to be a 0.368. So that's 0.368. And we're increasing from 0.368 up to positive infinity. Okay. Now at 0, which is that point, we have a minima. So the local minima is at 0.368. And if we plug that into our calculator, we're going to get a negative 0.368. So it's going to be down below the graph at the 0.368 at the same distance down. All right. What else do we have from here? I think that should be all. So what's 3? Well, 3 is the second derivative. So 1 disappears, ln of x becomes 1 over x. Here, x cannot equal 0, so that's a partition number. But again, it's going to be the nd. We already know it can't be equal to that. And so at 0, we have the no derivative there. And so it's everything to the right. So if we plug in a 1 here, we get 1. If we plug in a 2, we get a bit positive. So no matter what we plug in here, everything over here is going to be positive. So that's going to be always concave up. Okay. So concave up from 0 to positive infinity. So that really doesn't do a lot for us because it's always concave up. And so basically then we just have to kind of think about, okay, well, we really are only starting at 0. Now, at 0, well, that would be 0, but we can't have it at 0. So we have an open circle there. We'll call it an open circle. And then what's it going to do? Well, here we have a minima at, well, if we call that 1, so somewhere, and we call that 1, somewhere maybe about here, that's going to be our minima. And then after that, we can say, okay, well, at 1, it's going to be actually equal to that. And if we change our colors and kind of draw like we've been doing here, let's do it in colors. Then it's going to be kind of something like that. And again, that's not supposed to be curved. It's supposed to be this kind of a, well, anyway, you know what it's supposed to be. Hopefully. We'll do it again and make it hopefully better this time. So something like that. And again, scale is going to be different, everything else, but that's what it's going to be. We can't have it at 0 right here. But that's the minima, that's another point, and then it's concave up the whole way. And so that would be what we would get for this one. All right, so let's stop there and come back for another one.